Hey class, this is Gigi from Kauai Community College. This is a question on infinite limit. We are looking at the limit of this function approaching from the left and from the right of 1, and then to conclude whether there is a limit as x approaches 1. Okay, so if we were looking at when x is approaching 1, from the right hand side, we are saying limit as x goes to 1 from the right. And instead of writing it as a polynomial on the denominator there, I'm going to go ahead and factor that. And when we factor that, that will be x minus 1, x minus 4. So think of a number that is close to 1, and it is to the right of 1, so it's just a little bit bigger than 1. A number a little bit bigger than 1 minus 3 on the numerator is going to be roughly negative 2. On the denominator, you will have a square root of positive small number multiplied by a negative 3. Okay, so what you will have on the denominator now is negative 2 over square root of a negative small number. And you're thinking, wait a minute, how could the square root of a negative number even occurs here? Well, that is undefined, right? This right here is undefined. So then there is no limit when x is approaching 1 from the right. But a better question for us to go and look at really when we run into issues like this, we should be thinking, okay, so how did that happen? Why is that? Well, we should look at the domain of this function. Okay, so the domain of this function is anything except for when the thing on the denominator has to be greater than 0, right? Or the thing inside the denominator here has to be greater than 0. It cannot be 0, because it, and I say it, I really mean x squared minus 5x plus 4 has to be greater than 0. Why? Because you can only take square root of numbers that are 0 or higher, but we cannot have 0 on the denominator, so then this x squared minus 5x plus 4 has to be greater than 0. So when solving for this, we would say, well, let's go find the break-even point. And the break-even point would be 1 and 4, right? So when is it that our function is x squared minus 5x plus 4 is greater than 0? Well, let's go and pick some numbers to test. In between 1 and 4, let's say 2. 2 minus 1 is positive. 2 minus 4 is negative. A positive times a negative is a negative. Okay, now let's check a number to the left of 1. Let's pick 0. You'll have negative 1 times negative 4 is positive. And then here on the right hand side, you would pick, say, 5. That would be positive times a positive is a positive. So your domain is anything to the left of 1 and to the right of 4. That is why it is not even a good thing to talk about the function value when you are approaching 1 from the right. Meaning, what happened when your x is approaching 1 from the right? Well, there's nothing. You just don't go there. The function is not defined. It is not in its domain, right? So that is why there is no limit at that point, or approaching from the right. However, approaching from the left, it is in the domain of the function, and we can talk about the limit as that happened. X goes to 1 from the left. Again, the numerator is going to be x minus 3. The denominator would be square root of x minus 1 times x minus 4, which give us negative 2 all over square root of a, let's think about that again, right? When we are approaching 1 from the left, it is not yet 1 minus 1, so it's a negative small number multiplied by a negative 3, and negative small times a negative 3 is going to be a positive small number. Square root of a small number is still a small number, so then negative divided by positive is a negative, so this would be negative infinity. So we do have a vertical asymptote as our function goes, and from the left hand side our function would be approaching negative infinity, but there is nothing here to the right of 1. So what can you say about the limit as x goes to 1 in general? That does not exist. However, we do have a limit as x goes to 1 from the left of f of x is negative infinity because of the domain that you see here. Okay, so be really careful when you're looking at a function and make sense of its domain, really. Putting things together, that's what we are trying to do here in this course. Stuff that you have done before. Now, if something doesn't make sense like this here, then you would say, why is that? And so you go and you look at the domain, and that's why. Now here's a question for you. If I ask you, what is the limit as x goes to 4 from the left of f of x, what do you say? In this case, it will be just like part A because of that domain right here, right? And you're approaching the function from the left. That does not exist.